We are going to be looking at sequences of transformation. So, what do we mean when we are talking about sequences of transformations? We are talking about when two or more transformations are occurring to form one transformation. So, if we have two or more transformations occurring to form one transformation, then that is what we call a sequence. So, what would that look like? If we look at example 13, we are told that we are given the following graph and asked to determine the new coordinates of the triangle after the following transformations. The first is a reflection over the x-axis, and the second is a translation right 5 and down 2. All right, before I do any of these, the first thing I want to do is identify where are my coordinates currently. So if I look at my graph, E is currently at 5, 13. F is currently at 8, 10. And G is currently at 14, 13. Now, with these problems, what I'm going to do is I am going to use my ordered pair rules to determine where are my final ordered pairs going to be. So I need to take what I currently have, so my current ordered pairs, and I need to reflect them over the x-axis. So if I reflect them over the x-axis, if we look at our formula sheet, our rule to reflect over the x-axis looks like this. Remember, what this means is that x is going to stay the same, and y is going to change signs. So that means for each of these ordered pairs, I'm going to keep x the same. So for E, my x is still going to be 5, but my y is now going to change sign, so it's going to be a negative 13. F, same thing. My x stays the same. It will still be 8, and my y will change sign, so it will be negative 10. And then for G, x stays the same, 14, and y becomes negative 13. So that was my first transformation. That was my reflection over the x-axis. Now, the next transformation I'm asked to do is a translation right 5. Remember, right means I am adding. So I'm going to add 5 to my x-coordinate, and down 2 means I am subtracting 2 from my y-coordinate. So for each of these, I need to add 5 to my x-coordinate and subtract 2 from my y-coordinate. So for E, when I add 5 to 5, I'm going to get 10. And when I subtract 2 from negative 13, I get negative 15. When I add 5 to 8, I'm going to get 13. And when I subtract 2 from negative 10, I get negative 12. And then when I add 5 to 14, I'm going to get 19. And when I subtract 2 from negative 13, I get negative 15. All right, so those would be my final ordered pairs after my two transformations. So these are my final ordered pairs after my sequence of transformations. All right, let's look at another example. Number 14, given the following graph, determine the new coordinates of the triangle after the transformations. All right, notice we are now given a rule, but remember this rule just tells me I'm going to be subtracting 3 from my x coordinates and adding 8 to my y. Before I can add or subtract anything, I need to first establish what our current coordinates are. So looking at I is at negative 4, 10. J is at negative 12, 6. And K is at negative 8, 2. All right, so the first thing I want to do to each of these is I want to subtract 3 from my x coordinates. And I'm going to add 8 to all of my y coordinates. All right, when I do that, my new I is going to be at negative 7, 18. I'm going to actually do this in the margin over here. All right, my new J is at negative 15, 4. And my new K is at negative 11, 10. So that is after this first transformation where we are applying that rule. So we subtracted 3 from all of our x coordinates and added 8. All right, next I am asked to do a rotation 90 degrees clockwise. So again, if we jump to our formula sheet, then we would see that a rotation 90 degrees clockwise looks like this. All right, and remember what this means is we are going to change the sign of our x, and then x and y are going to swap places. So the first thing I want to do is change the sign of my x. So this negative 7 is going to become a positive 7, and then it needs to switch places with the y coordinate. So when I do that, I end up with 18 as the first named coordinate, which is my x coordinate, and 7 as my y. Same thing for j. We want to change the sign of x, so that negative 15 is going to become a positive 15. And then it needs to swap places with the y coordinate. So our next j is going to be 4, 15. And then last but not least, our negative 11 is going to become a positive 11. Then we are going to swap places with the y coordinate. So we have a new ordered pair of 10, 11. And that would be our final answer. So those would be our final coordinates after this particular sequence. All right, last example, number 15. If triangle ABC is transformed using the following sequences, a reflection over the y-axis, and then a rotation 90 degrees counterclockwise, which triangle shows our final image? Well, first thing I want to do is identify my ABC. So this is the triangle that I'm looking at right here. All right. So if we know that the first transformation is a reflection over the y-axis, that means that this triangle is going to flip over my y-axis. So if we flip our triangle over our y-axis, we actually end up with C here, B here. I'm going to erase this for a second because it's going to get in the way of A. And A here. So if we flip our triangle over the y-axis, then we would be at this triangle next. So that's our first transformation. All right, our second transformation says we need to rotate this 90 degrees counterclockwise. So that means I'm going to take this and I'm going to rotate it 90 degrees counterclockwise. And notice we can see if we rotate all of these 90 degrees counterclockwise, we are going to end up at triangle 2. So that would be our final answer. Now, if you wanted to use, instead of using the picture, if you want to use your ordered pair rules, of course you can always do that. You can find the ordered pairs of A, B, and C, and then you can reflect those over the y-axis, which means that you are going to change your sign of x and y will stay the same. And then from there, if you want to rotate 90 degrees counterclockwise, then you are going to change the sign of y and it's going to swap places with x. So if you wanted to, you can use your ordered pair rules as well. But if you can use the picture, sometimes it might be a little bit easier to do that as well. And that is our sequence of transformations.